Okay, ladies and gentlemen, let's go ahead and get to it. If you look at where we are, it's kind of a fun day. Today, your P1 Alpha is finished, okay? And it was not an easy assignment, was it? Not an easy week, okay? There are some really great looking projects in the exhibition channel, but I think there are also quite a few projects that are missing, all right? Not quite in yet. So if you are continuing to work on your P1 Alpha, you're not quite submitted yet, you've got 24 hours, all right? A little bit under 24 hours to get that in. 20% penalty, but hey, that's way better than 100%, okay? So whatever it takes, whatever you've got done, and make sure you submit something for P1 Alpha, okay? Don't let that 24-hour late period lapse. It's a difficult assignment. You've got a lot of interesting tasks that you had to at least get a draft in this week, okay? You got the whiteboard, right? I think you had fire alarm as well, okay? You had time of day, all right? Which were the hardest tasks for you? I'm curious.
Annoyingly and embarrassingly, getting NPCs to look in a certain direction.
Yes, getting NPCs to look at you when you get close to them, right? Yeah, that can be a little bit tricky. There are different ways to do that, and some of them have some pretty funky math that you have to do, okay? What else?
The day-night progression, getting it to go smoothly.
Yep, absolutely, right? Day and night progression. I couldn't remember if we require it to go smoothly or not. Like, do we still require it to go smoothly?
I'm not sure.
Okay, I thought we used to, and I removed that requirement, I think, last semester.
I don't think there's the requirement right now.
Okay. So that adds a little bit of difficulty to it, right? A little bit. But yeah, it can be difficult, right? To create the right component that's going to cause the sun to go up. But after it goes up, you have to have it come back down. So it's not quite as simple as you might think, right? Yeah. So know that this isn't a super hard course overall, but certain things in it can be difficult. By attacking those challenges and working your way through them, that's really going to help you grow, okay? If the entire course was super easy, might as well just be a YouTube series, okay? You can watch on your own time. So, do the best you can, all right? There's extra credit in this course, remember that. And if you get tripped up by a few things, hey, that happens, okay? Part of the learning process. You don't need to feel bad about that, okay? Just do the best you can to get these assignments in. Manage your time as best you can. You're going to be okay, all right? All right. But we now have a new assignment, okay? You've got P1 Alpha done. What does that mean? You've got P1 Gold, okay? What does P1 Gold mean? How many big new tasks do you have for P1 Gold? 2, just 2, right? You look at that spreadsheet. Let's go ahead and take a look real quick. You've got that spreadsheet of all of your tasks. Thankfully, this week, you only have 2 additional ones, all right? Only 2. And let's go down. We can see those golden tasks right down here. You're going to have a custom object and a custom interaction, okay? So thus far, you've been doing what I prescribe to you, okay? You've been doing the tasks that we demand. Now, you get to come up with your own task, okay? And this can be super ambitious and big if you want it to be, or it can be a bit smaller, all right? We don't want it to be super small, right? We are looking for a task that involves an additional object and some sort of interaction with that object that's unique, okay? And we want that interaction to have some sort of custom coding element to it, all right? This can be as advanced as the CSE simulator minigame, right? Do you remember this? The CSE simulator, right? It's a mini game. You go in, there's UI even, right? And they've got different game mechanics going on. You're hitting the button to try and do your homework on time, make those bars go up. You're trying to keep your social life intact by answering the phone. You're trying to eat and stay healthy. And then you get graded on. Your vision blurs, right? Now, the team that made this was an EECS 494 super team, okay? They had already taken EECS 494. They know game engines very well, and so they're able to move very fast, okay? You don't have to do that much, all right? You don't have to go that overboard I'll very much appreciate it if you do, but you don't have to, all right? It could be, and I think this is a really good one, right? You've seen the beer pong, okay? There's now a secret room in the back of the lab, and if you go there, you've got this room that has a wooden table and some beer pong little red solo cups. The cups have unique logic. They detect a collision with the ball. The ball has unique logic. If it touches the ground or the table, it kind of comes back and respawns. And you even have some really satisfying bits of juice, right? You have a score system as the cups go away. You have the sound and the particles that come out when you score. So this is about the scope that we're looking for in terms of a custom object and a custom interaction, okay? You go simpler than this and you risk losing some points. You go more complicated than this and you're going to risk losing some sleep, okay? So you can choose. You can do whatever you want. I encourage you to think about your time as a Michigan CSE student. Think about something fun, something interesting that is, really represents the amount of time you've put in, okay? Or your unique experience of the Beister building. Remember, in the future, people very well might watch these videos you're making. They might play the game that you've built. And through that experience, they're going to get a feel for what it was like to be a CSE student in 2024, okay? And so don't forget about the historical impact of the thing that you're making, okay? All right, so does anyone have any questions on this gold, P1 gold? A reminder, if you have skipped out on some of the tasks, okay, from P1 milestone or P1 alpha, or if any of those tasks are kind of incomplete or really buggy, this is also your week to fix those up, okay? Because we'll be grading those too. We're gonna wanna see everything. Every single task we're gonna wanna see at the end of this P1 gold. And something to keep in mind, you're not just submitting a video. You're submitting more than that. You're submitting source code. You're also gonna be submitting your personal portfolio website, okay? So if you don't have a personal online portfolio website yet, you're going to be making one of those as part of this assignment, okay? It's not too hard. We actually have a guide for you to follow to get a basic portfolio working, but you're going to have to organize some stuff. You're going to have to deliver more assets than in the past 2 weeks, okay? So don't leave this to the last moment. Otherwise, it's going to be really stressful. In particular, when you've got like a zip file that's a gig, okay, that is going to upload really slowly. So if you've got 10 minutes before the deadline hits and you're starting your upload, that's going to be really tight, okay? You better hope your Wi-Fi hangs in there like a champ, okay? Otherwise, you're toast. Okay, yeah, also a lot of points on this assignment. So 20% late penalty, you're now talking some serious damage, okay? So do the best you can, and yeah, then what do you work on next week, okay? You have an entire week off, okay? 494 students don't get that, all right? But in this course, you get an entire week off. Let's go. You can focus on other courses. You can relax a bit and have a good time. Yes?
So on the website,
Yeah.
Are we posting a link to like an itch build, like a 494, or is it just?
Well, no, you're going to submit a zip file that contains your entire source code, but it also contains a document which has a link, like sending us toward your portfolio. So you've got like some sort of website that is not itch.io. I don't think itch can count. And that website needs to have a description of the project and the technologies you use. So you'll say Unreal Engine, blueprints, blah, blah, blah. And then it has to have that video, a link to your video, okay? And the rationale here is that we want you to have a portfolio where recruiters can really easily see all the cool stuff you've done and all the cool technologies that you now know, okay? That really helps you get a job later. Yeah?
Are we going to upload our code to the original website?
No, you'll only upload your code to Canvas so we can see it. Yeah. Yep.
I mean, if we are using GitHub for a personal website, do you think it will be better if we upload code so the recruiter can see the connection?
I don't think we care very much if you upload your code someplace else. We don't want you giving your code to a student, another student, right? But if you want to link to your GitHub or something, I don't think that's the end of the world. I don't think you'll want to use just GitHub for your website because you'll need to embed videos and stuff. So chances are you'll create your own personal website. An example, aarger.com. This is my portfolio site. It's really old, but you can swim around in it. Now, in the past, if you went to this website and someone else was there, you'd actually see their fish as well, swimming around. That's where I got the idea for EECS494.com's game from. You can see other people if they're looking at the page at the same time you do. Yeah. Anyway, that's the kind of thing that you might make. You'll probably make a much simpler version of that. Okay? All right. You've got another film coming up. Okay, we watched The Matrix not long ago. Really fantastic film. Gives you a really good feel for culturally what people have been thinking about VR and AR. But we have another film coming up. Has anyone snuck a peek at it? Okay, anyone want to guess what it is?
Is it Ready Player One?
No. Anyone want to guess? Now, I'm not a huge fan of this film. I guess I think it's okay, but it's very culturally impactful, and for historical reasons, it's worth a watch. Have you ever heard of Tron? Okay, all right. So, we're going way back in time. 1982 film, one of the first major films to feature CG animation. We're going to be watching Tron, okay? Classic Disney film. So, I hope you look forward to that. We're probably going to be watching it 1 week from now, okay? Next Monday, we'll do the same thing. We won't have any lecture, and you'll get points by just being there. Otherwise, if you can't be there, you can watch it on your own, and you'll answer some questions in an essay to kind of verify that you've done so, all right? Okay. I've got a company for you that I want to show you, all right? And this is one that I think you'll find interesting, okay? You might even find it a bit funny, all right? This is Relax VR. Based in San Francisco, California, this is a company that allows you to turn any space, even a broom closet, into your very own spa. So let's take a look. This is Relax VR, and here is a video.
Relax VR's virtual reality technology takes you on a meditation retreat in a peaceful location of your choice.
I felt like I was really somewhere else. I was in awe, and it was really relaxing as well.
Our clients love Relax VR. It takes them to a totally different world.
Pretty incredible. I'm hovering above the moon.
Relax VR uses the latest virtual reality technology, and we combine it with proven meditation techniques to make you relaxed, like you're on vacation.
That was amazing. It was really incredible to be totally immersed in that environment. I've never seen the Northern Lights, but looking at it in the VR simulation, it looked exactly like how I imagined it to be.
There's decades of research showing how great virtual reality is in reducing stress and anxiety. It's the perfect tool to combine with meditation to help you relax.
I don't practice meditation regularly because it is very difficult to do with the VR headset. It was much easier to do. You have this beautiful environment around you and it takes you out of your mind more.
This is a very healing device. I also connect people with nature using essential oils during the massage. So I can see this being paired with essential oils. Each location would have a different oil.
We found it very, very easy to use. It works at the touch of a button. It's really easy to train people. It's really easy to operate.
Relax VR is an immersive standalone experience and blends beautifully with traditional therapies to take your spa experience above and beyond.
Okay, what do you think? What's your instant reaction? Let's go. Come on.
Kind of dystopian.
Dystopian.
But it's like, it's maybe more of a sign of the times than dystopian.
Okay.
Like it's powerful.
Sign of the times.
Because you wish that people could be in a relaxing environment all the time. So it's like, I guess I'm conflicted. I don't know how to.
It feels like we're really kind of resorting to some strange means to make people relax these days, huh?
Roundabout way to get back. Technology to get back to.
Yes. Technology stressing you out? Well, we have the solution for you, right? More technology. Anyone else? So it's kind of an interesting product, right? So the idea here is that you want to start off your own spa business, but maybe you just can't get the right amount of space, right? It's restricted in your dense city. Or maybe you just don't have, you want something that's really unique, okay? Something to help you stand out. You've got 5 different spas in your city, and you are trying to stand out somehow, okay? Let's see if we can immerse people and get them feeling comfy and nice. You can give them some immersive audio. We could show them something pleasant. And maybe that's a way to relax them, okay? Maybe, all right? Personally, this doesn't look super appealing to me, and I can't see it on this person's face. Can we see anyone with marks? Can we see any marks on there? What happens when you wear the headset for like 30 minutes even? There's a very good chance when you come out of that headset, you're going to see something on their face, right? You're going to see marks, okay? Usually red marks that surround the user's eyes. And when people go to a spa, that's typically the opposite of what they're looking to do, right? Another thing, how do you feel when you've been wearing the headset for a while? Heavy, a little bit warm, sweaty, right? Okay. For many people, the idea of putting on a headset, right, attaching something to their face makes them feel a bit claustrophobic, okay? It's not a super relaxing feeling. It's very immersive, but the headsets we have these days are not perfect. They're not like glasses. They're not super lightweight yet, okay? And so there are some questions that you have to ask here. I'm guessing not all of their users love this experience, but those testimonials aren't going to get onto this video, right? So some users have enjoyed the product, assuming these aren't the founders or people with a stake in the product. But we're always going to get kind of a skewed perspective here, okay? Anyway, what else do they have to say here? Use virtual reality, meditation, aromatherapy, right, and binaural beats to provide a deeply immersive relaxation experience. One cool thing is that they actually embedded a 360 video right here into the website. So we can actually see what it's like.
Become aware of your breath. The natural breath. Feel the breath flowing in and out of the nostrils. Observing the abdomen and chest as they move on each inhalation and exhalation.
Right? So you can see they've got 360-degree video. They're going to use smells. They're going to use sounds to try and get you feeling better. Does anyone go to sleep or fall asleep just listening to white noise or listening to their phone or some speakers? Yeah? Quite a few people do that. And so, can we immerse people to help them relax better? Maybe. The answer is yes. Okay? Beautiful landscapes, guided meditations. You've got a nice soothing voice, right? Trying to get you to relax. You've got audio, okay? And you're supposed to use smells as well to even more deeply immerse you. When we were talking about game engines, we said that smells are something that we typically can't utilize, your sense of smell, right? We're pretty much stuck to vision and hearing. But here we can actually do smells, okay? We can make it smell like you're at the beach. You can smell the water, right? Anyway, if you want to know how expensive this all is, it looks like you have to contact them. And as it turns out, in a previous semester, we did so. They emailed us back and sent us this PDF, okay? Now, this is a PDF that you get if you are a small business, because who is the client of Relax VR? Who does Relaxed VR actually sell to? It looks like they sell to spa goers, right? But is that true? No. Who do they sell to?
They sell it to the spas.
Yes. Their actual customer is not the spa goer. Their actual customer is the spa. Okay? And so that's who they're selling to. So you get sent this PDF, and you can actually look on it how much it will cost you. Here are all the options we've got. Here are the essential oils that you are supposed to use. Okay? I think they send this to you, actually. Okay, all this stuff. We got testimonials from Lavanya Day Spa, them trying it out. They've got different plans that you might use, okay? So 30 minutes long, you might charge $35 to $55 for this. And it's going to cost you $2, okay, as the company. Blah, 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 blah. Here's the package, what they'll send you. They're going to send you a white label virtual reality headset. I don't know what headset this is, but they've slapped their logo on it, so it's a little bit hard to tell. 75 hertz refresh rate, so we know immediately this is a cheap headset. Okay, probably inside-out headset. They're going to send you a bunch of oils. They're going to send you some diffusers. They're going to give you a carrying case, some Bose headsets, disposable masks, okay? They're going to send you, I'm not sure what this is. They're going to send you some designs for different sessions you could do, training so you can train your staff, okay? You don't have to train them yourself. A release of a liability form so you can have the customers sign away their rights, before they engage. That's a bit spooky. That's a bit weird. A carrying case for it all. They're going to send you some marketing assets. And how much for all of this? Well, they're going to give you new content every 6 months. They'll give you training. They'll give you phone support. And what this is going to cost you, if you want to rent this, you're going to pay them $600, so basically $700 you're going to pay them. And then you're going to pay them about $150 per month. Okay? So sound pretty good? Who's looking to drop the change right now? No? Okay, or you can buy, basically it looks like a lifetime for about $3,500. Okay? Is that more enticing? Raise your hand if you would prefer to rent here. Okay, raise your hand if you would prefer to buy. Okay? And then a lot of you aren't raising your hands because I want no part of this, right? Why would you prefer to buy?
If I was a small business, I feel, and I don't, but if I did think that this was like a money-making opportunity, I probably wouldn't want to pay this company in perpetuity.
Okay. Makes sense. What if you're nervous? You're kind of interested, but you're a bit nervous about the company. You think, I might want to cut my losses after a month or two, send the headset back. You might go for the rental option, right? They know that, which is why they have this initial fee, okay? Just to try this out, we're going to charge you a big chunk of change just for you to be worth our time, okay? This is the ROI that they think that you're going to be able to accomplish. If you do 2 treatments a week, you're going to make $360 per month, which means you'll be able to kind of make that back in a few months, okay? If you manage 6 treatments per week, you'll make it back even faster. And they're assuming you're charging $45 per session, okay? Anyway, so it's very interesting, right? They've prepared this financial information because they know that they're talking to and trying to sell to a business instead of an end customer, okay? And that's maybe the biggest takeaway here. Sometimes you make a product, but you have the wrong audience in mind. You think you want to sell to the customer, an end user, right? Because that's what you are. That's what you're used to. You're used to being on the other side of that transaction. But often, you are not selling to the end user. You're selling to some sort of intermediary or middleman or some sort of business, B2B, okay? And then those businesses down the chain, downstream, they sell to the actual customer, okay? So anyway, kind of an interesting company. As far as our evaluation, social impact, right? This isn't necessarily helping someone get their limbs back, all right? But who knows, right? If you've got a bunch of people out there in a busy city that don't have good access to spas, maybe there is a niche that enjoys this kind of thing. I don't know if it's going to be super big, but it might be out there. And that's why companies like this exist. That's why they're able to get money. Sometimes it's hard to tell until you've tried it whether this business opportunity is going to be big or not. Okay? Financial sustainability, they do have a plan. Okay? They've done some numbers, and they've got a few options. So it's at least pretty clear that this company is trying to make money. They've been around for several years at this point, at least. So maybe they've got just enough traction to stay around, or maybe this is working out better than we think. I've never found a competitor in this space to them. If it was a huge opportunity, they're just raking in cash, they would have a lot of competitors. There would be a lot of businesses in this space. XR emphasis, yeah, you want to immerse someone, right? VR is uniquely good at that kind of thing. You might ask, though, right, is that XR element going to be perfect, right? Are people going to enjoy having red marks on their face when they leave the spa? Are people gonna get freaked out by that, by having something strung to their face? It's hard to say, okay? Can you immerse someone and relax them with 2D? Yeah, definitely. Can you do it without any visuals? Can you just do it with audio? The answer is yes, okay? So maybe kind of middling on XR emphasis as well. Anyway, it certainly seems like a novel idea, so I'm not sure why novelty is not up here. But a pretty cool company regardless. All right. So anyone have any comments or questions on this company before we move on? Yeah.
When you think about it further, it does have potentially like life-saving. Like think about someone suicidal in New York City or
sure.
Russia.
Yep.
This could show them that there's more to life than whatever they're experiencing.
Yeah, absolutely. Right. So maybe there are a lot of people who have very stressful lives. They go home, they play video games for an hour, and that's their way of kind of relaxing, right? Kind of getting their mind to a healthier state. And you've got people, who really benefit from that kind of thing in a life or death context. So absolutely, absolutely. Okay, so I've got some announcements for you. Roblox, the famous kind of game engine in the cloud, right? It's kind of, I think of it as kind of an open sandbox game engine for children in particular. Roblox has hired so many of my students. We have, I think, currently 7 of my students are there, and almost certainly more Wolverines are there. And so this is a company that has taken a lot of people in your shoes in the past, and they might be looking to do so again. Roblox is going to be on campus tomorrow, Tuesday, from 5:30 to 6:30. They're going to be in Dow 1005, 1005, and might be a really good opportunity to drop off your resume, okay? Ask some questions. Again, they really love our students. Our students are a great fit for what they want to do. And so take that opportunity if you can, all right? Okay. And by the way, if you want to get to these announcements again, right, just go to the lecture document and everything I talk about will be there. Okay, click that button, you'll be there. On Thursday, we have Epic Games. The Wolverine Soft Student Game Development Org has set up a call with Epic Games. And so that's a great opportunity to ask some questions, to get to know the recruiter a bit, and I'm sure you'll have an opportunity to submit games to them as well, okay? You can talk to them about what you're doing in Unreal Engine right now. And if you've taken some of the other courses, including the architecture course, Epic Games is one of the few companies out there that makes their own game engine. Students who have made their own game engine is a pretty rare thing, okay? So definitely don't sleep on that. See if you can talk to them if you want to. Should be an enlightening talk at the very least. A reminder, when you are finished with your VR headset, in this course, you should place your headset, kind of wrap it squarely on the table like this. That keeps the cord safe, keeps the hardware safe. Please do not do this. Don't let the cable kind of hit the ground or like sag off of the desk. The problem here is that it's very easy for people to trip on the cable. It's very easy for people to accidentally roll over the cable in their chair. That damages the cable, which might cause the headset to become useless, okay? And these headsets are not cheap, not at all. So please take care of your headsets. Please clean them up, organize them after you are finished with them, all right? Okay. P1 Alpha is due today, and P1 Gold and Culture 2 is launching today as well, all right? A lot of people say that this week is actually pretty chill, okay? Last week was pretty tough. This week, you're just catching up on some of those tasks that you missed, and you are working on some pretty fun new tasks of your own design, okay? So, should be a chill week, hopefully, and allow you to catch up on anything you missed, all right? All right, so what I want to do, you've heard about the topic of components, right? We've been talking a bit about components. This idea that when you're in a game engine, you create this chunk of logic. You know, you create some blueprint code. Or if you're in Unity, you write a little C# file. Now, that code that you wrote doesn't just get slapped into the objects that you care about. It actually gets packaged up into a reusable component. And then you drag that component onto many different game objects to reuse that component in as many locations as possible, okay? You've been creating a lot of components on your P1. Now, in Unreal, it's a bit funky because sometimes you put your logic directly onto the blueprint, and sometimes you put your logic onto a component, and that component then goes on to the actor, okay? In Unity, it's much more simple. In Unity, you're not writing any code unless it's inside of a component. In Unreal, maybe you write code in the component, maybe you write code directly on the blueprint actor. Okay, it's a little bit more messy. But I want to talk to you today about the topic of components in general. I'm guessing none of you have really thought about components or heard about them in EECS 280 or 281, right? Not until you take one of my courses do you start running into components. And they're extremely powerful. There's a reason that pretty much all game engines use them, okay? So today I want to talk about components versus inheritance, something you're very used to. I want to show you a game, okay? Have any of you heard of a game called Scribblenauts? Anyone? So this game is absolutely amazing. The people who made this game was actually a surprisingly small team. It's a game made by a company called Fifth Cell and Warner Brothers, okay? And this game has a unique twist. It's a puzzle game. It's a puzzle game where anything you type, oh goodness. All right, we need something to take care of this undead wizard. Someone name a weapon.
Knife.
What's that?
Knife.
A knife?
Yeah.
Oh, it's not going to be. We need something heavy duty.
Oh.
A gun.
A gun? What kind?
Bazooka.
Bazooka. I type bazooka and I've got a bazooka. Oh, I shot myself. Oops. Okay, well, we can restart the level anyway. Okay, so I need another word. Let's bring a friend of some sort into the world. Give me a word. Give me a word. Come on, let's go. What do you got? Give me a word. Shout it.
Dragon.
Dragon. Okay. We got a dragon. Now, what if we want a certain kind of object? Okay, give me another. We need something to fight the dragon. Come on, let's go. A crossbow. No, I want another character to fight the dragon.
Wizard.
A wizard. Okay, what kind of wizard? This is a big dragon, so I want a big wizard. And you know what? I even want a ice wizard. We now have a big wizard made of ice. Okay? You know what? I want a big fire flying wizard. Actually, I want a witch. Fire. Oh, did I misspell it? Big, flaming? Here we are. So we now have a flying, flaming big witch. Uh-oh. So the witch turned the wizard into a frog. You know what? Let's do flying Cthulhu. Oh no. It's riding the dragon. This is the problem. Can I use this? Pick up. Okay, and attack. All right, there we go. Okay. So I want you to realize how amazing this software is, right? With a small team, they were able to create a game that almost literally has everything in it. And in this game, your challenge is to solve various puzzles by thinking about things you can bring into the world, from tools and weapons to beasts and animals and characters, okay? In fact, not only can you bring these things into the world, but you can give them adjectives. So I don't just want a wizard, I want a flaming wizard, okay? I don't want a witch, I want a flying big witch, okay? And so the question for us should be, how on earth do you make something like this with a small team? How is it even possible? Okay? And so that gets us to our talk for today. Okay? How do you do all of this? Well, the answer is going to be massive amounts of code reuse. Okay? If you've only got a tiny team, you need to be very efficient and productive, okay? You need to have some incredible architecture in order to program all of these things, all right? So 2009, created by two companies, Fifth Cell and Warner Bros. Fifth Cell made the game, Warner Bros. Published it, and Fifth Cell is very small, okay? So I think only like 50 people. That's really small for a game studio. The idea here is you can create any object just by typing it. And I mean, you can create any object, okay? Pretty much any object, right? You can type something like a professor, and poof, there it is, okay? You can type something really obscure, like a jackalope, okay? And poof, there it is, all right? And you can give all these things adjectives, which is amazing. A seemingly unlimited number of things and variants of those things can be brought into the game. So as engineers, our main question is, how on earth does a smallish team of like 40 to 50 people make something with an infinite amount of logic and content in it? The reason, as we're going to discover, is really intelligent code reuse, okay? Inheritance, yes, but also components, composition as a design pattern. This is what you're used to seeing. Okay? You, in this course, are used to seeing components. This idea that we create some logic, but then that logic we want to be reusable. So we bundle it up, and then we take those bundles, components, and we pop them onto whatever we want. Often many different objects. Okay? Reusing that code in hundreds of different places. Right? In Unity, it looks like this. You click on a certain game object, i.e. an actor, and you see in the inspector on the right in the details pane all these different components. You can turn them on, you can turn them off, you can add them and destroy them at runtime, and you can tweak them because every component is a class and every class has variables that you can change, okay? Same thing with Unreal Engine. Though Unreal actors tend to have fewer components and those components bigger and more deluxe, they too tend to have components and you can customize them just like that, okay? So if you take the game engine architecture course, you will also basically build out this kind of game engine, a game engine that supports components, a C++ game engine that can run and execute Lua code every frame. It's really cool stuff, okay? So composition, right? Composition. When you ask the question of how to reuse code and assets, inheritance is what you're used to, okay? Do you remember inheritance from like 280? I think that's where that tends to be introduced. When I was going through, it was a blackjack, right? You had a card class, and then you had a bunch of subclasses, child classes, that would derive from card, and you do some cool things with polymorphism that way, okay? Inheritance is like classic, one of the earliest methods of mass code reuse that you tend to learn after you've learned classes, okay? Inheritance has almost ubiquitous support among programming languages, right? Java, C++, Python, right? All the top languages have it. And the usage is basically like this. You tend to create a parent object with a bunch of really common reusable logic and data. You then have subclasses that inherit that data and that logic, but sometimes we change it, we tweak it, we override it, okay? So you remember, if we've got a human parent class and that human has functionality for eating, for sleeping, all that stuff, well, a student is a human, but a slightly different kind of human. It overrides some of those things. It introduces new data and new versions of functions, okay? And so there you go. If you want to do this kind of thing in code, it tends to look like this. And you can see the C++ going on right there. So you look at this, right? That's C++. In Unity and in Unreal, there is a lot of inheritance being used, okay? Right? You can see that when we're dealing with affordances, when we're dealing with our selection and interaction system, we used a lot of inheritance, okay? But that's not everything, okay? Blah, 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 blah. So I've got a scenario for you, okay? Let's say that you've been hired by a game studio. Congratulations, okay? Industry can be a bit tough to break into. You've done it. Good job. All right? You work at a game studio, and one day your boss walks in and says, hey, I would like you to make me a panda for the upcoming video game, okay? And so you need to think about an inheritance hierarchy that the panda would work well in, because you know that you've been asked for a panda today, but tomorrow your design lead is going to ask for something else, and you want to reuse some of that code. So you might create an inheritance hierarchy like this, okay? You've got an ISA hierarchy where panda is at the bottom. Now, a panda is a bear. A bear is a mammal. A mammal is a living entity. A living entity is an object. This is the start of an inheritance tree. And you distribute pieces of data and pieces of code throughout this chain because you know you're going to want to reuse it in the future, okay? Now, the next day, your boss comes in and says, hey, I just watched the Frozen film, right? All the kids are into it. We need a frozen panda, an ice panda. Okay, now answer me this. Where is this ice panda going to go in your inheritance ISA tree? You want to reuse as much code as you can. Yes? Yeah, absolutely, right? So we already have the logic for a panda. We just want to customize it a little bit. So we're going to stick this under panda. We're going to inherit from panda. We have the ice panda. Awesome. Very good. Not too bad. But unfortunately, things are going to get pretty rough for you, okay? Soon, but not yet. Next day, your boss, your lead designer, has been reading a lot of horror novels, getting really into it. They say, hey, we need to have a Lovecraftian panda in your game. So this is a panda with wings and with some skin problems. Where are we going to put it? Where does it go? Where do we put Lovecraftian panda?
Would it be next to Ice Panda?
Yeah, exactly. So we don't want to put this under the ice panda because then our Lovecraftian panda is going to inherit a bunch of ice stuff, which makes no sense at all, okay? So we do want to inherit from panda, get most of the panda attributes and logic, and then we'll add some unique stuff to make it more Lovecraftian. Makes sense to me, okay? You have a massive problem, though, when your boss the next day walks in and says, please, will you give me the ice snake? And from this point on, your life will never be the same. Why? You now have a massive problem. Where would you put it? Okay, you say to yourself, well, a snake isn't a mammal, so we should probably go down this part of the chain, right? Let me see if that's the example I give, okay? Well, first, let's say you want to reuse the ice logic, right? That means you'd put it under ice panda, right? Like this. But this is horrible, isn't it? This makes no sense at all. Because now your ice snake is inheriting panda logic from the ice panda. Yes, we're getting the ice part, but we're not getting what we want. We're getting panda stuff in our snake. Makes no sense. It's terrible. Okay? Something you might think of is you could create your own reptile category, right? Let's go back up the tree, and instead of going into mammal, we'll create reptile, snake, ice snake. That seem a lot better? There's a problem with this. What's the problem? Have you ever heard of the concept of dry? Don't repeat yourself. Have you ever created a bug by copying and pasting your logic? And then later say, oh, I should have just made a function. Okay? In general, the problem here is that we have ice logic in two different parts of our tree, our chain. You have just duplicated the ice logic, the ice data. So this duplication is a dry violation, okay? This is the kind of thing that makes your code unmaintainable. If you discover that later there's a bug in your ice logic, you have to remember to fix it in both places, and you won't. When you forget to fix it in both places, you've got a guaranteed bug, instant bug, okay? So the dry principle, and this is important to remember, okay? This stands for don't repeat yourself. It's the idea that every piece of knowledge or logic, we want there to be one single authoritative copy of it, okay? No duplicate copies. And the reason is that when you update one of those copies, you have to remember to update the rest. And if you don't, you're toast, okay? So, right, it improves maintainability when you do this, and it reduces the chance of copy and paste bugs, all right? So we want to avoid putting redundant duplicate data and logic into different places in our inheritance hierarchy, okay? And so you can see that ice snake and ice panda, this just isn't going to work. We can't do it, okay? What else could we do? Well, we could create an ice object and put ice snake under it, but then we have the same problem. We got ice logic in two different places. We could move panda up here, right? But then we're not reusing the bear logic that we really want to be reusing, okay? And so, gosh, like, what are we doing here? What are we doing? What happens if you want the ice panda to melt and become a normal panda at runtime during gameplay? What do? Can you change the inheritance hierarchy at runtime? Not usually. You would have to despawn the ice panda and then spawn in a totally separate panda and then try and copy all the data over, and Nasty. That just stinks. Okay? So, what are we going to do? All right, we're chasing our tail here. We can't find any sort of way forward that doesn't have a nasty element to it. There's no good solution. What do we do? Well, one thing you might say, right, is that this is actually a very common problem. Have you ever been organizing your stuff? You've got all these things, you're trying to put it into folders, real folders or even digital ones, okay? Let's say that you got a bunch of photos on your desktop from a recent trip. You're trying to categorize them into boats and cars, right? Get organized. And then suddenly you see this. Uh-oh. What do? Is this a boat or is it a car? And you're kind of like, it's both, but I have no way to categorize it as both, right? The best you can really do is put this image into one of them and then try and remember where it was, okay? So this stinks. Sometimes ISA hierarchies, that's what inheritance is, just isn't what we need to model our data properly, okay? You might say, well, wait a second. This ice snake really should inherit from multiple parts of our chain. This ice snake should inherit from snake, but it should also inherit from some sort of ice object class, okay? This is referred to as multiple inheritance, when you inherit from multiple classes instead of the usual one. You should know that this is banned by a bunch of the world's most popular languages. You're not allowed to do multiple inheritance in C# or Java or PHP, Ruby, or other languages, okay? And when something is banned by so many different popular authorities, you should ask yourself why. Does anyone know why multiple inheritance is very deadly? Can get you into some trouble.
You can get into circular inheritances as well.
Yes, you can. One of the nasty things that can happen, and you should know this for interviews actually, okay, it's called the deadly diamond. And here's an example of the deadly diamond, okay? Let's say you have a parent class human. That human has a sleep function. Now we have two classes that derive from the human parent class. Both of them override that sleep function. They change it. So we got new versions of the sleep function in the student class and the instructor class. Unfortunately, we now have someone who is both a student and an instructor at the same time. And that was me when I was a grad student, okay? And so the question here is, which version of sleep does this class take? And many languages do not have a mechanism for allowing this class to choose whether it's the student sleep that should run or the instructor sleep that should run. Okay? This is referred to the deadly diamond. You'll get compilation issues. You'll explode. You might not know what's going on. This joke worked a lot better when I was actually a grad student because I was having a tough time with my sleep schedule because I was both a student and a faculty member at the same time, which was kind of weird. Okay? Anyway, here's the bottom line. Inheritance sometimes is a real big pain to use, and it's not always the right tool for the job, okay? We need some sort of new approach. The ISA relationship status just isn't what we need, okay? Now let's turn instead to composition. Let's stop thinking about inheritance and let's think about components, okay? Entities in composition, right? Entities, actors, game objects. They're made up of components that are reusable. Instead of saying ISA, we say HASA, okay? All right, instead of a bird, ISA, living entity, we say bird has feathers. Bird has a beak. Bird has the ability to fly, okay? Here's how it's usually structured in the code. You usually have some sort of entity class. This is like an actor or a game object or whatever you want to call it. This is literally just a container for components. Like you might say a vector of components, okay? Or a list of components. This is your panda, this is your snake, okay? Then each component has life cycle functions. In Unreal Engine, what are the life cycle functions? They're event tick, event begin play, okay? And all components will have those, right? These tend to be your icy, okay? Your fiery, your render, or in your case, the AF toggle affordance, or the AF message, or AF quit, okay? Right? In Unity, these components tend to look like this. They're little packages of logic that do something interesting, okay? If you look at this code right here, now you haven't done a lot with Unity yet, but if you look at it for a second, you might be able to gather, especially if you look at its name, what it does. This is a component written in C#. Its name is sine wave movement. When you add this component onto an actor or a game object, what is going to happen? This is what's going to happen. You can add this component onto a piece of ground, like we see there, or you can add it onto an enemy turret. In the former case, you now have a floating platform, which is very common in platforming games. But in the latter case, you now have a flying turret enemy, okay? And that's the magic of components in composition. You're creating little bits of has-a logic, okay? This piece of ground has the ability to float. This enemy turret has the ability to float, okay? And thus they become interesting, right? So now we're going to create those objects, those game objects, those actors that we created previously, the panda, the snake. But we're going to do it not using inheritance, but using composition, okay? And you know what? We're actually going to do this. We're going to do this when we come back in 5 minutes, okay? 5-minute break, we're halfway through. Think about, as you're on your break, think about how and what kind of components you would need to create these actors. And think about this, can you reuse any of the components across those actors, okay? It's going to save you a lot of time. Okay, see you in 5 minutes. Okay, let's get back to it. So we have moved from the world of inheritance, ISA relationships, to the world of components, composition. These are different. These are HAZA relationships, okay? So when you ask yourself, well, what makes up a panda? Okay, what does a panda have that makes it a panda? Have you ever heard this phrase right here? Famous phrase. If it looks like a duck, if it sounds like a duck, if it walks like a duck, it's probably a duck. Have you ever heard that phrase? Okay. That phrase suggests that what you are depends on the things that you can do. Okay? So what can a panda do? What does a panda have? What do you got? How would you describe a panda? Let's go. Come on.
It's big.
It's big. Okay, it's got some heft. Size. Okay? Yeah.
Furry.
Fur. It has fur. Okay? So let's create a fur component and let's stick it on the panda. By the way, can you think of any other objects or actors that have fur?
Bear.
A bear. Okay? A bunny. A wolf. So once we've created this fur component, it actually becomes easier to create other things that have fur. Okay? What other things, what does a panda eat?
Bamboo.
Bamboo. So it's a herbivore. But a panda actually is also a carnivore. Pandas will eat meat as well. Okay? A panda is a living entity. Okay? It's not a rock. Okay? A panda has hunger. It has the need to sleep. So let's create a component called living that will have some floats in it that will store that information. Okay? Now, this is a game object. This is an actor that should be visible. So let's give it a render component. Now, in Unreal, this would be the static mesh component, right? Now, a panda isn't just a carnivore, it's also a herbivore. It can eat plants and bamboo. So, taken together, what do these two components make the panda? What do we call that when it's both a carnivore and a herbivore? An omnivore. That's right. But notice, we didn't create an omnivore component. We created the omnivore effect by using two components together. Okay? And so, if you say, well, I want to create an ice panda, you can reuse all of these components. We already made them for the normal panda. And we can add on a unique ice skin component. Now, we created this ice skin component. Can we reuse it anywhere? Once we have ice skin, there was another object we needed to create that had icy skin, right? What is it? We spent all day creating this ice skin component.
Ice snake.
Yes, exactly, the ice snake, okay? The hope here is that you build out all these components and then you reuse them. Eventually, you get to a point where you have so many great components, you don't need to write a single line of code to create the next thing, okay? So, if we want to go toward this Lovecraftian panda, we can reuse all of the normal panda components, but then we can add the flying component. We can add the zombie skin component, okay? And if we want to create that ice snake, we can introduce scale component, poisonous component, and then we can reuse that ice skin logic, okay? So, right, compare the two approaches. On the left, we have the HAZA approach, and we were able to make all of the objects really easily, right? Like, really no problem. On the right, however, we have the inheritance hierarchy approach, the ISA approach, okay? ISA versus HAZA. In our situation, the ISA approach was creating problems, okay? Big problems for us. With the HAZA approach, it was much easier. But you might notice, right, the old questions of where does the ice snake go are kind of answered for us. And the question of what happens if the ice panda melts, I'm going to ask you this, okay? Challenge for you. Let's say we have the ice panda, but it's really hot and sunny in our game. And so after a few seconds, we want to convert this ice panda into a normal panda. What do we do? This is extremely easy. One line of code.
Remove ice skin.
Bingo. We just removed that ice skin component, and now it's a normal panda. Okay? Because guess what? Can you remove and add components at runtime? Yeah, it's super easy. Barely an inconvenience. You do it all the time, right? Okay. All right, some bonuses. How do you make a scaly panda? Let's say you want a cool snake panda hybrid. What do? Well, you take the scales component that you made for the snake and you just pop it onto the panda. All right, easy. How do you make a flying zombie snake? You already have the flying component and the zombie skin component. Let's just put those onto a snake. No big deal, okay? Components are really amazing. If you write good, high-quality, reusable, flexible components, you can mix and match them. You build up this incredible toolbox of components, and then you don't have to know how to program a line of code, okay? But you can take those components, slap them together in a different group, a different assortment, and boom, you got something completely new. Imagine how awesome that is for your non-technical teammates. Now, you're not used to this because you've been in a CS program for 4 years. But you're going to go to industry and you're going to be working with people who have never programmed in their life. They see a line of code and they run the other way. Okay? How are you going to work with them? The answer, usually, you create really great, wonderful components, and then you just tell them, hey, you don't have to write any code. You want to create something new? Look at the components I made for you. Put them together. See if you can make something cool. Okay? That's how it goes. Okay, question.
Have we made a component yet? Really?
Yes. We made a lot of them. Every affordance that you made
Right, so that's what I was saying.
was a component.
We haven't made nothing like.
Yeah. You're going to make a lot more components in Unity. You've already made a bunch of components in Unreal, even if you don't realize it. What's that?
An affordance would be a type of component.
If you go to the affordance classes that we made together during the lecture, you'll see that its parent is the affordance class.
Sure, yeah.
If you go into the affordance class, you'll see that its parent is actor component.
Oh, I remember you saying.
Yep. So every affordance is a component. Okay? All right. So, you might have noticed something, though. I snuck something by you. Did you notice it? We actually have a problem here. Because guess what? We complained previously that our ICE logic was duplicated, right? In different parts of the inheritance hierarchy. Well, guess what? We did the same thing here. Did you miss it? Right? We have skin logic in the ICE skin component, but we have skin logic in the zombie skin component. So the skin logic is duplicate, right? That violates dry. That means that this approach is no better than our previous one, right? How could we fix this? Here's how. Okay? It's not composition versus inheritance, okay? That's not what this talk is about. This talk is about composition working with inheritance. Because guess what? We just solved our problem. Boom. Right there. Because you can have components that are inherited to each other, okay? And thus remove the duplicate logic, all right? Hey, you've got multiple components that are kind of similar to each other. Zombie skin, ice skin. Well, guess what? Create a skin parent component class. Now you can have your zombie skin and ice skin inherit from that skin class, and now you've resolved your dry problem. This is to say that inheritance and composition are not necessarily rivals, they are complementary. You can use them both, and they should both be important pieces of the puzzle when you're trying to reuse code and write less of it, okay? Stretch your code, allow it to do more things, okay? So, if you've ever seen this famous book on design patterns, they really love composition. They love this approach, okay? In fact, in there you can find the line, you should, in general, favor object composition over class inheritance, okay? Now, I say you should think about them separately, and you should use the one that makes more sense for your situation, okay? And you should keep in mind that you can use them together. You can solve a lot of problems that way, okay? On The Sims, as a very concrete example, if you had an object like the slip and slide, well, the sim can't do anything with that slip and slide until you add a component to it, okay? So maybe the slip and slide would have the can slide component, okay? But it might also have the deals fatigue component, because when you interact with the slip and slide, you start to get tired and your comfort metric will go down, your comfort motive, okay? But if you look at this radio back here, this radio object might have the listen component, okay? But it also might have the fatigue component, because you're going to enjoy listening, but you're also going to get a bit tired when you do so, all right? This bathroom had a component that I worked on, which is the waiting line component, okay? This component was very powerful. You could put this component on any object, the TV, the toilet, the bathroom, the radio, the fridge, the computer, and if you put that waiting line component onto any of those objects, now the Sims would actually form a waiting line if a Sim got there, but another Sim was actually using it. And they would form this nice organic line, and it was super cool, okay? Very, very cool. So composition is super powerful, right? A question, though, is how do you get composition? You want to program using composition? Okay, how do you do it? Well, you could choose a game engine that features composition as a built-in way to do things. Unity is one of those engines, okay? I've already shown you an example. Every game object, every actor that you click on in Unity uses composition. You click on a game object and it's literally just a container, a list of a bunch of components. Those components all do different things. Those components can all be turned off or on or added or removed at runtime, and they all have their own little bits of configuration, basically public variables that you can alter to change the way that component behaves and what it does, okay? And so you use Unity, you're going to be dealing in components all day, okay? That's just how it is. In Unreal, you have a little bit more flexibility. You can deal in components if you want to, and I highly recommend it, okay? In Unreal, you've got interactable actors everywhere, and those actors usually have components on them, okay? The one that almost all visible actors have is called static mesh component, okay? But you might add your own components on there. For instance, the AF toggle actors component, or the AF message component, or AF quit component. And you might have many of them on there as well. You probably created an AF time of day component, or an AF advanced time component. So you'd slap that on there, and then every time you toggle the light switch, the sun would rise or go down, okay? And so, components everywhere. Unity, Unreal, everywhere, okay? It's really cool. If you take my EECS 498-007 Game Engine Architecture course, you're going to be making components. In fact, you're going to be writing the C++ engine code that powers and brings Lua components to life, okay? Super fun, super interesting. It might blow your mind, okay? It is very meta programming that you have to do to bring all that stuff to life, okay? So these characters that you see, they're called actors in our engine. These actors are defined in a scene file, okay? And these actors, right, so there's actually 2 background actors. Each background actor has 3 components. A transform component that holds where the object is, what rotation it has, stuff like that. But each one also has a moving background component that causes it to move and then hop over, right? And it has a sprite renderer component that allows it to render an image, okay? So this footage that you see, the beautiful background that's constantly moving, the starry night background, it goes infinitely, but it's only 2 pieces. You know how it works? It works like this. Mer, 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 mer. two pieces leapfrogging each other to create the illusion of an infinite background. Okay? So it's pretty cool. This is just basically me shilling the course. Okay? You need another upper level CS course, you got to take this one. All right? Very difficult course though, so please don't take it with 482. Okay? Good luck if you do that. You can build your own composition framework out of C++ in your own time. You don't need to choose an engine to do so, okay? You can write a class that's like this, a component class, and you say, well, what does every component need to do? What does it need to be? Well, every component needs some sort of start lifecycle function. In Unreal, it's called event begin play, right? You need an update lifecycle function. In Unreal, that's called event tick, I believe. Right? In Unity, it's start. And you often want to destroy lifecycle function as well. Okay? So you could then create a transform component. It derives from that component base class. Now you know, due to polymorphism, you know that this transform is going to have a start, an update, and a destroy. Okay? And it's going to have some other stuff too. Okay? Then you can have some sort of actor or game object or entity class, which is really just a list of those components. Okay? When you update, when the game updates, you go through each component and you call update on that component so that it can have its tick lifecycle function run. Okay? You can then have some additional functions for adding components into that vector, into that list. And now you've basically created a super basic component-based framework. Okay? You can do this in any program. It doesn't have to be a game. Could be a calculator app. Could be some high-performance trading software. Okay? But you find components a lot in creative software because it's just so useful, okay? In creative software, in games, in film editors, okay? You need the ability to quickly mix and match pieces of logic to experiment and find out what works best for your game or your film or your app or whatever, okay? So that's why components show up all the time in creative software, okay? All right, you can check out example. You can get this example code if you want to via that bit.ly link right there if you want to check it out later. In summary, okay, this amazing game that I showed you seems impossible, right? We have to have infinite game objects. We have to have infinite adjectives. The only way a small team is going to be able to do this is if they reuse the heck out of everything they can, and they did. They used a lot of inheritance, and they used a lot of components, in particular for those adjectives. So we made an ice wizard, right? An icy wizard. We made a fiery witch, right? Those two adjectives, icy, fiery, they're components. You can add them to anything. You could have a fiery sandwich. You could have a fiery pole, a fiery Cthulhu, okay? It's just going to work. Those are components being attached to whatever object you specify, okay? So, composition is a flexible alternative or complement to inheritance. It's really nice because it can be mixed and matched at runtime. You can pull components off. You can add new components on. I don't think you've done that yet in Unreal, but you might do that in Unity, okay, during Project 2, okay? It's really great for any sort of scenario that involves properties or adjectives, okay? And it can work very well as a complement to inheritance. Okay, and I think that is all I wanted to show you. Okay, so the reason this is here is because this is actually the talk I gave in 2017 that got me my faculty job at U of M. Okay, and that was a really fun talk. One beautiful thing about Scribblenauts, this game, I want you to imagine for a second that you have a young child who's kind of learning how to spell, learning new words, right? Learning how to read and write. Can you think about a cooler game to emphasize those abilities than Scribblenauts? Hey kid, you want a dragon? Hey, you can have one if you can spell it. That kid is going to learn the vocabulary, the dictionary, as fast as lightning, okay? So I remember, we'll talk about this more a bit later. but my reading skills dramatically improved after I played a certain game. It was a Game Boy game. It had a lot of text in it, and it was super cool. You might say it was all the rage. Which game was that? You remember? Now, this is kind of after your time. There's a tiny little obscure game called Pokemon. Okay? Pokemon had so much text, it had the coolest characters, but I never knew what to call the characters, right? I would play the game and I'd see an awesome new Pokemon, go, whoa, and I'd have to run the game over to my uncle. I remember it very clearly. I'd bring the Game Boy over to my uncle and say, hey, what is that? What's the name of that? Can you tell me what that piece of text says? And they would, okay? At that moment, it became clear that I had to learn to read right now, okay? Right away. If I wanted to play this awesome game, I had to learn to read. And so I learned to read. Anyway, okay, we'll talk more about games and education and XR and education a bit later, okay? So look forward to that. Does anyone have any questions on the topic of composition and inheritance? Okay? If it feels weird to make all these components, it's gonna feel very natural by the time you're done with this course, okay? So don't worry about that. All right, so we can talk more about the inner workings of VR, but I don't think I want to today. I think we're gonna save that for Wednesday, okay? For next time, okay? Your project is due on Monday, okay? 1 week from now. If you need help finishing it up, if you're a bit behind on something, please raise your hand. I'll be walking around. We're going to start office hours about 20 minutes early, so you get 20 minutes of bonus office hours, okay? Yeah, put them to good use, all right? Everyone, thank you for coming. I know there's some stuff going on. There's a career fair and stuff like that, but it's always good to see you, okay? We'll see you next time. Okay, everyone online, see you later as well. Bye-bye.